Hello, my name is Milani Mayo, and today I'll be doing chemical nomenclature on ionic and molecular bonds. An ionic compound is a metal and non-metal. The metal loses electrons and becomes a positive ion, and the non-metal gains electrons, becoming a negative ion. Molecular compounds contain two non-metals which share electrons. For my first example, I have binary ionic compounds. These are elements that have one metal and one non-metal. My first example is NaCl. First step is to find the metal and the non-metal. In this example, my metal is sodium and my non-metal is chloride. When using ionic compounds, when naming them, the "ide" at the end of the non-metal, or the end of the non-metal changes to a "ide." So in this example, the chlorine would change to chloride. So this would be sodium chloride. My second example is MgO. The metal is magnesium and the non-metal is oxygen. So the oxygen would change to "ide," giving you magnesium oxide. My next example is transition metals. Transition metals have more than one possible charge. For my first example, I have FeCl3. First, you change the charge into a Roman numeral. So this one, you would get the Fe, which is iron, and then you get 3 from the chloride charge. The non-metal would still change into "ide" at the end. So this will give you iron 3 chloride, like in the example here provided. Next, I have CuO. First, you change the charge with the Roman numeral, so copper would be 2, but because copper has a +2 charge because oxygen has -2, giving it a +2 charge. Then you would give the non-metal the "ide" at the end, giving this copper 2 oxide. Lastly, I have polyatomic ionic compounds. This contains ions made of more than one ion that acts as a single charged unit. So for my first example, I have Na2SO4. I use the polyatomic compound sheet for these examples, but first I identify the metal in the polyatomic ion. The metal is sodium, and the polyatomic ion is sulfate, which is the SO4. So the name of this compound would be sodium sulfate. And for my second example, I have NH4 and NO3. This one, you have two polyatomic ions, ammonium and nitrate. The two polyatomic ions join together as one compound. Thank you. For my next video, I'll be defining moles. A mole is a unit used in chemistry to count particles like atoms and molecules. This is essential because atoms are so tiny that this allows scientists to measure and compare these substances. Mole's relation to mass and the number of particles. So given here is the formula. Moles equals mass in grams divided by molar mass in grams divided by moles. And then this is the number of particles formula, which is equal to the moles times 6.022 times 10 to the 23rd. So mass into moles into particles. So mass equals the moles, which you could get by the number of the particles. Here's my example. You have 18 grams of water. That's 1 mole. So 1 mole times the 6.022 times 10 to the 23 gives you 6.022 times 10 to the 23 water of moles. So whatever moles are represents that unit. Here is part 3 on Avogadro's number. This represents the number of a particle like an atom, molecule, or ion in 1 mole of a substance. This is represented by 6.022 times 10 to the 23. The connection with atoms, molecules, and moles. So like I just said, this formula helps represent how to measure atoms, molecules, and moles in 1 mole of a substance. My first example, I have this conversion. You have 2 moles of oxygen atoms. How many atoms do you have? So first I took the 2 moles right here and I multiplied it by the 6.022 times 10 to the 23 over 1 mole, and then I got 1.204 times 10 to the 23rd atoms of oxygen. Real world analogy. If you had 6.022 times 10 to the 23 grains of rice, this could cover the whole entire world in about 20 meters deep. My last video is on molar mass. Molar mass is the mass of a substance measured in grams per molecule. This is represented in grams over mole. This tells you how many grams of 1 mole of atoms, molecules, and ions weigh. This is calculated by adding the atomic mass of all the atoms. For my first example, I have H2O. This is the molar mass of a compound. For H2O, the mass of hydrogen is 1, and then for oxygen, it's 16.0. Then I multiplied those by 2 because there's 2 hydrogen atoms, and then I added 16 from the oxygen, and then I got 18.016 grams over moles. This is the molar mass. For converting between grams and moles, moles is equal to grams divided by molar mass, and then grams is equal to moles times molar mass. An example of this, I have 36 grams of water. How many moles is that? So moles of H2O. I took 36.0 grams divided by 18.02 grams of moles because earlier we just calculated the molar mass. So I added that to 18.02 grams over moles, and I got 1.998 moles. And this is rounding equivalent to 2 moles of H2O.